Hi guys, today we're going to be going over a teleportation problem in USACO. And so in this problem, basically Farmer John hates hauling around cow manure and he wants to streamline this process, so he comes up with the invention, a manure teleporter. So instead of just hauling a manure cart between 2 points, he can just use the manure teleporter, right? So Farmer John's farm is built on a single straight road, and any location on his farm can be described as its position on the road. So like basically a point on a number line. And the teleporter is described with two numbers, X and Y, where basically the first portal or the first station of the teleporter is at X. And then if you go to X, you will be teleported to Y. Okay, so in this problem, basically Farmer John wants to transport manure from location A to location B, and he's built a teleporter that might be helpful in this process. And the key word here is might. So it could be helpful, but sometimes just walking the distance is faster. So we need to help him determine the minimum amount of total distance that he needs to haul the manure using the tractor. So basically in this problem, um, our input gives us A and B, and these are the starting and ending locations of basically this is where he starts hauling manure, and this is where he has to haul it to. And this is X and Y, which are the coordinates for the teleporter. So there's a teleport station at 8, or a teleporter at 8, and there's a teleporter at 2. And you can go to this one and end up here, and you can also go to this one and end up here. So let's see. First, uh, we could just move our manure manually, right, from 3 to 10. But that's going to take 7 time units. And remember, we need to give the minimum distance Farmer John needs to haul his manure in his tractor. So let's see if we can find something shorter than 7. And so what we can do is we can move our manure to the teleporter at x equals 2, right? Or at position 2. So that's going to take 1 unit. And then we will be transported to 8, right? Position 8. And then we just need to walk to position 10. So in total, that takes 3 units. And you can see the explanation here. And so because the minimum amount of steps that you need to take is 3, then that will be our answer. So let's take a graphical, or I guess a visual approach at this, because I know it might be a little confusing. Okay, so we are at position 3 currently, and we have to carry the manure to position 10. So the first choice that we can do is going just from 3 to 10, right? And this isn't really a great option because we have to walk manually for 7 steps, right? And so what we can do instead is, as we just went over, we walk to 2, and then we come out at 8, and we walk to 10, which is just 3 steps. So we basically have 2 options, right? 2 things we have to look for, and that's whether walking manually is faster or using the teleporters is faster. So some pseudocode that we can use is we can go from the first position, right? So the first position is A, and we can go from A and we can see the closest teleporter to A, which is here. And then after we use that teleporter, we're out at whatever other teleporter there is. And basically, we'll just see the distance between that other teleporter and B. And we'll compare those two, right? So the teleporter distances versus the manual distances, and we can just get whatever's faster. So yeah, now we can go ahead and start coding. Okay, so we have our buffered reader and our print writer set up, and we have some static variables. We have A, B, X, and Y. A is the starting position, B is the destination, and X and Y are the coordinates of the teleporters, or I guess the positions of the teleporters. And we set everything up here, and after we're done with our program, we close the in and the out. And for our initialization, we'll just create a string tokenizer to take in A, B, X, and Y. And then we'll put all those in. And then since it's all the same, we can just copy paste it 4 times. And that should be good. And then what we need to do is we need to see whether manually walking or teleporting is faster. So we'll do a math.min. Um, actually, we can just do this in one line. So or actually, sorry, 2 lines. So we'll just save it to an int for now. Um, and then we'll just say math.min because we need to find the minimum between the manual walking and using the teleporters. And the first one will be math.abs and it'll be b minus a just because we don't know sometimes sometimes b might be greater than a, sometimes a might be greater than b, so we need to be safe. And then the next one is basically finding the nearest teleporter to each of these and just calculating the distance between the teleporter and A and the other teleporter and B and adding those together. So we'll do a, first we'll use math.min and then we'll do math.abs and x minus A and math.abs y minus A. And this will basically find us the closest teleporter. And then we have to add the B version of this, right? So math.min, math.abs, and it's going to be x minus b and y minus b. Okay, so now that we have this, right, basically all that's left to do is just print it out. And so remember, this is just finding the minimum between the actual manual walking between point A and point B and walking to the closest teleporter to A and adding that with the distance between the closest teleporter to B, right? So we're just finding the shorter one because sometimes the teleporter isn't really effective. And so now we can go ahead and submit. So yeah, as you guys can see, it passes all the test cases. And if you guys have any questions about this problem or just USACO in general, please feel free to leave a comment. And as always, thanks for watching to the end.